All right, I think we're back. Sorry about the delay. Thanks, everybody. Welcome to Atomic Friday. We've got some really cool topics to discuss today. So just a couple of housekeeping items. There is a Q&A box at the bottom. You can ask your questions. Mike and I will be moderating the questions, and we'll have different points where we pause as we go through this. So it is being recorded. It is being streamed on YouTube, and Paul and Ross have a cool Jupyter notebook they'll talk about that'll be released along with some code that we're going through today. So as you're going through and you want any of the code snippets or samples, you'll get all of that. So I'll go ahead and let Mike do a quick introduction, and then I'll get us kicked off. So
awesome. Thanks, Casey. Thank you, everybody, for joining. I hope you guys find this very interesting. Mike from Red Canary. Casey and I work on all the research activities over on this side. So
cool.
Pass it back.
All right, yeah, so I'm Casey with Red Canary, also on the research team. Really excited. We've got Paul Ewing and Ross Wolf from Endgame with us today. The reason why we brought them on was they've done some really cool stuff with Eql, a language that you'll learn more about today, as well as some really good detections that mapped to some of the Atomic Red team that we've been working on. So we thought it was a good topic to bring forward to you guys. And so with that, I'm going to go ahead and turn it over to Paul and let you guys go ahead and run with it. So take it away.
Sweet. Awesome. Yes, I'm going to assume that everybody can hear us, so please interrupt me if you can't.
Yeah.
But yeah, it goes without saying, just to kick things off, yeah, thanks for having us here today. We're super pumped to kind of nerd out on Eql. We really want to embody this whiteboard session. So as Casey already mentioned, feel free to use the chat to ask some questions in the Q&A, and then we can field those along the way. But at least before we dive right in, I'm Paul Ewing. I mean, who wants to waste time on intros? But I'm a researcher at Endgame, kind of practitioner at heart. And next to me here, actually, it may not look that way on Zoom, but sitting right next to me, we got Ross.
Yeah, right next to Paul. I'm Ross. I'm also a researcher at Endgame. So I work a lot on Eql or EQL, ready for the holy wars whenever those begin. A lot of that and driving detections for malware for miners attack framework.
Cool. Yeah. So maybe let's make sure Ross can share his screen here. As Casey already alluded to, we really do want to, as I said already, embody this whiteboard session. So what we thought would be pretty cool to do this is we just made a Jupyter notebook. We'll kind of mix in the notebook with, of course, a command prompt and kind of do some things live and whatnot. But at the end of the day, we'll release all this stuff at the end of the talk, all these example queries, etc. But at least before we just dive right in, for those of you out there that don't know what Eql is, I mean, quite literally, as you can see here, it's the event query language. And really what that means to us is with Eql, we tried to provide a unified language to hunt, search, and detect. That's really the main thing. When we were looking at some of the options out there, and just I'd say in the community at large, we were struggling to find a single approach to have one language where we could do some hunting and data stacking, some sequential questions, and then eventually evolving that into a more robust analytic posture. Hey, how can we evolve this more primitive hunting question and expand that to an analytic? So that's really what we tried to solve here with Eql. We'll really, through the montage of the demo today, I hope you guys have a really good feel of that. But it's really about asking these very, almost English-like questions. That's how we want them to read, where you can kind of have that vibe and that feel that you can share these amongst your team, but yet they're not just pseudocode and you can actually query the data at hand. So with all that being said, I mean, no time like the present, right? So I think I'll just kick it to Ross here and actually just start with a fresh install, and we'll just kind of get things going.
So if anyone does want to follow along, it might be a little tricky, it might be a little quick, but we do have this read the docs set up. So just equal.readthedocs.io. And right on that first page, just to getting started. So if you want to install Eql, you're going to need Python first. So 2.7, 3.5, most versions will be fine with. And then the next step is, is installing it through pip. So pip install eql. So let's download it from Python's package index. any requirements it needs, and there we go, we're installed. So now I can double check that it is installed, just equal version. Great, so it's installed. It's also in my path. So my Python's configured to allow that. And then one thing we've got as well is this example.json file, just to double check that for sure it's working and data is going through it. This is just some really sample process data, just 5 events, just to kind of get the picture of what we're looking at.
Yeah, and if you didn't see that, the just because there may have been like a little lag on the share screen, that the link to the example JSON is right on that homepage of the Eql read the doc. So feel free to just pull that if you want to follow along.
Yeah. Yep, right here, this sample JSON file, just click that down, it should be good. So we're going to run this query straight out of there. Equal query -f, mine's at this data folder. And then we're just going to search for a process for explorer.exe. So we can just say process where process name is explorer.exe. And I'll get into the syntax in just a bit, but we're just double checking that everything looks good. So there's our one event. So we are already able to query over that array of events. And then we can, I also have JQ, which is just like a JSON query thing, structuring things. So I'm just going to do JQ just to pretty print this so we can see a little more clearly what it is. And there's explorer.exe running by researcher. So that's the gist of how we can use Eql. We can use it in the command line. A lot of our demos today are going to be more within the notebook, just because writing a command line and doing a lot of queries really quick is really difficult, and staring at JSON eventually can make your eyes burn. So we're just going to avoid that a bit. And then yes, this is what we just ran. We can go within Eql. We've got some rules for the next question would be like, how does the language actually work? How do I use it to ask questions? So I'm just going to walk through some of the high level things of what we can express and how to search for things. So as we saw with the process where process name is explorer.exe example, every query is over events. So when I say event, it's basically anything that has a timestamp. So something that happened. It's usually, we kind of say that every event has like a type of thing that it is, and then all the things it used to describe it. So those are going to be like keys and values. So anyway, you've got event where some condition. And that might look like process where process name is explorer. And you can make these conditions more specific to gain some, as you would with like many query languages, like and or not, those are supported. You can compare fields to like values and strings and do wildcards, less than. So right out of the gate, there's all the standard things that you'd expect. Within Eql, we also have function calls. So I could say the length of command lines greater than 400 characters. You could do something like that, which can exist in a lot of languages, but a lot of them end up adding more keywords and making the syntax a little trickier. So we just kind of have been erring on the side of simplicity, and that's something that we try to go through with everything that we're doing. So make it simple.
Just a quick question, Ross. Is that extensible to functions, or those are things that you guys have built into the language?
That's extensible, and then there's as well this API reference on here. I won't get too into the weeds quick, but you can actually add your own custom function and hook it up just like within Python. So if you are running your data in and out of Python, you can hook it up.
Got it.
Yeah, so that's
cool. Thanks. Yep.
And then you can also use in for some, again, syntax simplicity, checking something against like a list of values or comparing things to each other. One other thing with Eql is we want to make it easy to express relationships between other things. Specifically, processes are kind of treated a little like first class in here, where if I want to say like, show me a network activity for this specific process or for a descendant of something, we kind of add this concept of relationship. So I could say, give me a network event for PowerShell that's not a descendant of Explorer. And normally with a lot of other things that we were looking at, other languages, it'd either be like some complicated like SQL join, or maybe some like transactions or Splunk searches or sub searches or something. So try to like take that concept and make it as simple and intuitive as possible. Because honestly, I never remember the difference between like inner and outer and left and right joins. So just try to not have to worry about that. Yeah, we can do descendants. We could even like chain them. So we could say, find me a file event that's a child of a process that was a child of another. So you could, if you really wanted to, you could make like assertions on the entire tree. So there's a lot of flexibility within there as far as like process lineage goes. Another quick pass is we've got sequences. You could say that I'm looking for an event that looks like something, now that we know how to describe a single event. But it's also followed by another thing within maybe 30 seconds or within some window. And maybe you could be more particular and say, these also have something in common. So these are just examples of what sequence syntax looks like. Hopefully this is straightforward relative to where we were just coming from. And then within this one example here, you could say, over a 30-second window, I'm looking for a network event coming into port 3389. Grab its source address, and now look for like a Windows security event, a logon failure or success, and grab the IP address out of that. And now all of a sudden you've enriched those together.
Mm-hmm. Yeah, and like another good thing, just to like foot stomp the cool thing about sequencer, because I actually don't think we will touch on this later, but a really kind of gnarly application of this would be like a host enumeration, right? So if you think about, first thing attacker wants to do, who am I, ipconfig, netstat, let's run all those commands. All those things are, of course, just like legitimate admin tools. You can't write a rule to look for that. So exactly to Ross's point, you could be like, hey, in this sequence, if I see X number of enumeration discovery-like commands run within a minute window, or maybe that's too long. Maybe you want to be like, hey, I want to look for a script. So does this run within 10 seconds? That's exactly where we were like, sweet, we just went from something that happens all the time to now an actually analytic that could be meaningful. Just like good example.
Yeah.
Yeah, cool stuff.
And similar to that, we also have, there's also sometimes where like maybe you looking for some specific enumeration commands, but you don't know the right order. Those are called joins, and I guess that's an overloaded word, but it's essentially an unordered sequence. So I could say, I'm looking for a user that did all of these things. Or maybe you're joining this example. I'm going to scroll down just a bit. Down here is I'm looking for one PID or process GUID or something that has this process command line, this network, this registry, this file, but they all have this in common. So you can express something like that pretty easily, not have to worry about ordering. And then one other thing before we start getting into our examples are our data pipes. So these are pretty similar to Unix piping, or even like the PowerShell pipeline, where you pipe events through. So you could say, okay, well, give me process things. I want to pipe them to count, and then you get a total count, or maybe you want to count a specific field. You can also do like unique, filter, do a unique, but enrich it with the number of times number of duplicates there were. And then like head, tail, and sort. So those are just a handful that we have so far, and those are similar to functions. Those are easy enough to extend without having to like rewrite a new syntax. And then I'm not going to walk through all these functions, but again, there's a lot of functions. You can express some really interesting things with these. I think there's about like a dozen or so. So with all that in mind, let's go and actually start searching for things. So we've got that example.json file here that we looked at earlier with 5 events or so. So let's start asking some questions of that with equal. So just for a first sanity check, are all the events there? You can search over more than one event type. So you could say any event type. I want any event type where anything is true. So you say anywhere true. It's just a quick way to express just give me everything.
And also too, just like we don't want to just start like diving in. We could turn this into a Jupyter notebook session, but just so everybody knows, to level set, we don't want to assume too much, but the comment that Ross has right there, that's Eql comes with a CLI. So if you are following along at home, you can run these queries, just like how Ross just showed, -f, point to your JSON file, and then the query we have, the little function we have is what the actual Eql query is. It's just, hopefully everybody appreciates how clean this will work, but we at least wanted to show that you can do all these commands at home, but we're going to kind of fire through and just kind of use the notebook, just so we can kind of play around with the syntax. But anyway, yeah, sorry, Ross.
And I also just like the tables.
Yeah, that's right. No one wants to look at raw JSON for the next hour? What?
Yeah.
All right.
So even though we know this data set, we've already looked at everything, so we could just make up questions, but we're going to do that anyway just to kind of get a feel for syntax-wise what it looks like. So again, that explore.exe, we already searched this one. Find explore, and there's the one event that matched. This is more of a Jupyter Notebook Pandas thing, but if we only wanted to look at a few columns, we could do that too. That's pretty easy. You can just take those results and kind of like a SQL select or something. Mm-hmm. You can also start to finally ask more interesting questions, like for this data set, what are the parent-child process relationships? So we could do that by asking, by looking for anywhere where the parent process name is not null, because the first one it was, there's not really a thing there. But then we would just count for the entire pair instead of just counting everything. Count parent process name and process name, and now you're getting tuples. So I know that for all of these combos, there's only one pair per combo. And
also, like, again, leave it to the guys that are here talking about Eql that invest in it to like already start doing shorthand tricks. We didn't say it, but just so you know, where Ross just has parent process name does not equal null. When you just start with kind of a data model condition, it automatically appends or prepends anywhere where true, right? So it's basically saying any event where parent process name does not equal null. So just wanted to let you know that we're not just throwing away our where syntax. It's there.
Yep. One other. Next. Oh, there we go. So if we want a more interesting data set than this tiny contrived example, we can use Sysmon. So we've got a guide. We've got a guide here for if you haven't played around with Sysmon before, getting it installed, how to configure it. So there's a link to a couple configuration files. Then we also have some PowerShell scripts. Windows event log stores things in XML, and it can be kind of painful sometimes to parse. So we've got some helper scripts to run that and to get things as a file. And so I could just run this command here within PowerShell. And so I'm going to import, we've got this, so in order to run this, we do have this helper script in our Git repo with just these useful functions for parsing the command log. So if you wanted to run this, you grab that script. Mm-hmm. And then just a matter of running this command. So import module, so that's equal lib utils script events.ps1. Okay, so that's imported. Now I can want to get the latest processes, convert that to JSON and store it as a JSON file. So this is going to hit the Windows event logs. Sysmon install. Yeah.
First demo failure. That's okay. Well, I will say the point here though is we at least wanted to show that, if you do, like, this is mostly for like the researchers out there. If you're just running some detonations and you want to detonate some tests and grab those logs, Eql's, like, one reminder here is that Eql it's just a language, right? So if you just want to collect Sysmon locally and run it against static JSON, cool. If you have your own data source that has its own schema, we'll talk about that a little later, but you're golden. So the point here is, and then, we're not talking about a backend here, but, one kind of cool aspect of this conversation today is that, someone out there really gets inspired to be like, well, we should have an elastic backend and we should do this, but, by all means, we'd love to work with you on that. But nonetheless, I will say we have this Sysmon data and we're going go through like an analytic process, but probably a good sanity check here with Casey to make sure that, is there any pressing like core, just as a heads up, we're going to go into like hunting and analytics here soon, but any core Eql questions?
Not right now. There's a question that I think I'll get to in a little bit, just around sort of integration with some other languages, but I think we're good. So I do see that question, but I think I'll let you guys keep going with where we're at, and I think you're going to touch on it a little bit later. So
Right. Yeah.
I actually do have a question, Paul or Ross, on the performance side of it all. If you pull, I don't know, a pretty large size sysmon file, what would the performance be like running against, like, I don't know, I don't want to say a gig, but maybe like 500 megs or something? Just
This
depends
part,
on the query. And
that's,
everything.
I guess, yeah. So part of that's still going to depend on how, if you just use the command line utility, since that's Python parsing JSON there, that'll probably be a bit slower than writing something like on top of an existing backend and using that for indexing or something.
Yeah.
But one thing that we do have is within some, I believe we have example files actually, right? I'll get to those in a sec, but we've got a few where we'll actually take like JSON lines and gzip it, so it's actually like, it'll be a lot faster. And everything within the Eql Python engine is all like stream processing. Yeah. So as soon as, if an event, as we're streaming over that JSON file, we'll decide, do we use this event or not? If we don't, throw it away and skip it. So we don't have to like store everything in memory and do these expensive joins after. So that ends up helping with performance and speed.
Mm-hmm. Yeah, I think that's the right way to say it too. Like optimizing the language is one thing, but Mike, I think it's a good question, because I think really what you're getting to is, at least right now, like we really emphasize like the language, the analytics. We'll talk about that, but I think you're really kind of bringing up that point of, if you start talking about like an architecture, really that comes down to like your kind of what your backend database is and how you want to hook up Eql to like the streaming side. So of course we could, that may send us down a rabbit hole as far as a conversation, but yeah, it's a good question.
No, yeah, totally. Just super curious about like, if you detonate so much data and you forgot to dump the last 5,000, now I got a gig event log or something,
Oh yeah. Just drowning in data. Yeah.
There's
help with that at least. Yeah.
Another question did come in, just if we have time, or you guys can keep going, but the question was kind of related to like, is there a specific event ID that we're looking at in Sysmon, or could you, like, obviously the sample data was just processed, but and you may touch on it later, but just thought I'd bring that up. Someone was asking about specific.
I think that's
I think we'll get to some of those later when we talk about more of the Sysmon schema.
Perfect.
How it fits.
Cool.
So the next thing would be if I'm not going to live scripts are one thing, live debugging is another. So I'm not going to figure out exactly what that was. But one thing we could do is like, let's say we want to detonate this technique. So this should look familiar for a lot of people on the call. Since this is atomic red team test. So we are going to, I'm just going to detonate this one. Already so many tabs. I'm not going to find that. Right there, at least atomic red team. Yeah, we're going to detonate this test for the Red Server 32 technique. So I'm just going to take this command line, run it, and then pretend to grab sysmon logs. Okay, so that ran, and then it would rerun this get latest logs or get latest processes to generate my own file for sysmon. And now that I've imported that, so I've run the command. Next thing would be to actually, now that you've got your file generated, you don't really need to do the red part anymore. You do the red first as a thought, like figure out what like the attack technique was, and then the question is like, okay, now that I know what the technique was, how do I detect it? So we've got some data sets in our GitHub repo. I'll share this again so everyone can see all the links, and we've got a lot of resources that should be helpful. So specifically within my data folder here, I've got this one. This is the one I'm going to look for. So we're going to pick this technique. You can download it raw there. How do I turn this into a detection? So I could take this one file and kind of ask just at the very high level, what is in this file that I just generated? So we can look for all the event types. All right, mostly image loads, it turns out. So maybe there's something interesting in there. And so this is just kind of like the analytic process that we would go through. This is a much simpler example, but that way we don't have to be worried too much about the technique and kind of focus on the part of the language. So maybe the next question would be, for each process in here, what are the types of events that I see? So there's a lot of like Red Server 32, which makes sense. That's the command line we ran, and some CMD. There's only one network event, so that might be worthwhile as well. So the next thing might be, okay, well, what were all the commands that I saw for this process that keeps bubbling to the top? We ran it, so again, we know, but this is still a useful thing to look at, to be like, okay, there's the raw command line, and maybe we want to focus on this script object, DLL. So I wonder if there's any image loads for that. And so we can say, are there any image loads for the process Red Server 32 with that as the image name? And there are, and there's this one right here. I think the next question would be like, what was that network activity again? So we're just going to figure out like what all is in this data and how could it be useful? How could we turn this into a more robust detection? So what's the network activity? Okay, there's an outgoing network connection. So how could we take all of those three things that might be noisy and combine them into a more worthwhile analytic? And we could say within this data set, I'm looking for an equal sequence for a process, and then it loads that script object, and then it does a network connection. And then just count how many times that happens. Like, okay, so that happened once in here.
Yeah, I'll say too that I almost like feel guilty, but when you're not demoing, this is like that. I'm just drinking coffee and just like hanging out. This is like piece of cake. Sorry, Ross. He drew the short end of the stick, but I get to be the hype guy. But no, basically what you're seeing right here is like what led us to the desire to make equal, just so that that's clear. I'm sure anybody that's following along could have been rolling their eyes like, oh, okay, like I saw some like things I could have done with JQ. I saw some things I could have done with like Spark SQL. I don't know, like we just were doing some simple counting and uniquing. If your bash foo is good, easy. And then even the conditional statements. We're not saying we're doing anything earth-shattering by saying, hey, match this event where this thing in the schema exists. But yeah, what you're looking at right now, like our intention here is that this now is an analytic that has a much longer, shelf life, half-life than a pure signature-based approach. And that's really where we're trying to get at with equal. I mean, so we're not touching it here, but we can define macros. We'll show this later, where you can make these all variable names and make it a more longevity over time. So then really the equal rule, this analytic more so, is a pure behavior-based detection, at least, well, we can go down like a philosophical behavior random, maybe like an overused term, but at least we're getting more closer to a behavior-based approach for detection. So anyway, sorry to interrupt, Ross, but I always get super pumped.
Yeah. Good stuff. I think the other thing too is then that becomes a way to share between research teams or groups looking at a particular activity that can be expressed this way and then shared amongst a group. So yeah, all right, cool.
Yeah, it's a really good point, Casey. I guess it's always really, it's super awesome. Like keep sharing, like here's a VT link, here's some hashes, of course, samples, share that in the community. But yeah, you're right. If we could like share these almost like, this reads pretty well as a form of pseudocode, but then equal, you can actually use it to detect something. But yeah, we'll even show like a spearfishing example later and talk through that.
Cool. Awesome.
Hey, this is Keith. I promise not to talk, but I naturally can't help myself. So one of the things, one of the things that's really cool about this, we're chatting about this, just, one of our like kind of research meetings internally the other day, is that, as a company that's like built this stuff at scale and spends a ton of our time doing detection engineering, like we spend probably close to as much time like building and maintaining our rules language as we do actually writing rules to find behaviors. And so I think that's one of the things that's so neat and promising about Equal, is that particularly for companies, like most folks go headlong into this and say, hey, I'm just going to go like buy all these tools and collect all this data, and then I'm going to write a bunch of detection, not realizing that like the engineering side of just asking questions can take you, like that could be a full-time job for like multiple people, right? Like really, really easily. So definitely don't want to like undersell the value of just like having an extensible language that you can use to like ask questions like this in a really dynamic way. Like it's a super, super hard problem And like the better you get at detection, the harder the problem of maintaining that language becomes. So hopefully people kind of like think through that a little bit. And as you start to mess around with this, and as folks start to think about like how they can use this on their own, like definitely a consideration.
Great. Yeah, appreciate it, Keith. Yeah, go for it, Ross. I guess, oh yeah, maybe sharing the actual analytic, but yeah, go for it.
Yeah, so we've got, and sharing that too, like once you, like there's writing the language, there's actually like writing things in the language, and there's like the duplication of work of everyone rewriting like the same queries in their own languages too. So, so hopefully like helping with that. And I think we'll talk about the whole library we've got of analytics so far. But this, yeah, we could take this one. We've got an analytic for this. This one is broken down a little bit more atomically, so this one doesn't have the sequence in it. I think probably for a reason. And that's the cool thing here about this. Paul's going to talk about that in just a second. Is that we can have them at various levels of fidelity. So we could say one that's just incredibly atomic, but maybe more error prone, or more noise prone. But then we could have one that combines a few different things together, has some more smarts and has higher confidence, but maybe that one's like harder to run or has just like less compatibility with platforms. Like Elasticsearch is only going to give you so much, or like Spark SQL might only give you so many things. So the simpler it is, the more shareable it is, but you run the risk then of like more noise. But anyway.
Yeah, sure. So, I mean, so since you're on Equilib, like
Yeah.
we go back, I'll talk like briefly about this, because then we can go like right down into like hunting cases, since we're about 30 minutes in or just over. So for anybody following along, you may have been just like, whoa, like where did I just end up? If you weren't paying attention or didn't see some of the recent posts about Equal, we released a in parallel, tangential, however you want to think of it, analytics library to accompany Equal, right? So we just thought it'd be too confusing to have everything in one, so we just had Equal as a language in its own repo, and now the analytics in their own library. And so what that really means, much like how Ross just showed the pretty kind of the atomic version of the image load analytic, we can host all these analytics, and really this could be a place where we can share them. So we already talked about, our tongue-in-cheek maybe atomic blue to your atomic red, but yeah, Ross, if you want to click on like atomic blue detections, basically what we did is all of these analytics, which are just about like 40-ish right now, so we're going to invest in the near term to just keep pumping out these analytics, but we can tag these analytics to n number of times that we can relate them to different data sets, right? So in this case, we basically said, hey, here's this series of analytics where they map to atomic tests. So here they are as atomic blue detections. Kind of shout out to Tony there. We had some open PR, so he got those merged just the other day. So we got some other contributors in the list now. So this is great as far as a way to be like, okay, cool, this is a tag data set. Maybe we could have different packages, etc. But even if we start thinking about MITRE ATT&CK, because we all love MITRE ATT&CK, Ross, if you want to click on that real quick. Yeah. Keep in mind that atomic red, awesome, more atomic to test things, but these detections, we want to have more widespread use. So where we have the atomic blue detection, we now can overlay those same detections to the matrix. And this is a growing list, but just give you an idea of where we're taking this thing, of where we're going to start having more detections throughout the matrix, of course. So that's kind of like, this is the analytics library that hopefully, whether or not you want to use Equal or not, I mean, I hope you at least enjoy reading some of the queries, and you could read them as pseudocode and get an idea for how to use them yourself. But they all work with Equal, of course. Now, the other thing worthwhile to bring up here is Equilib, as we call it here, also accounts for normalization of data. So I think there was a question about this earlier. So what we can do is part of Equal is we can convert your query to your data source, to your platform even. We can also convert your data to an Equal kind of default schema. So what you're looking at right now is more of, if you want to think of it, the Equal data model. I mean, by all means, we're not going to be too Napoleon here and be like, hey, this is the data model that everybody must use. I mean, we could obviously work on this together, or you could fork the repo and build your own data model. But at the end of the day, this worked for us. So we said, okay, this is the data model that Equal will use. And then if we click on Sysmon, I think there was a question about this earlier, Casey, to your point. Now within our sysmon event structure, we can be like, okay, throughout sysmon events, we can map this to our equal schema, and we can start doing little tricks along the way. So if you notice, process name or process path, if you will, is really referred to as image by sysmon, which is fine. We're not poking at that, but we also have process name. So really, we want to get the base name out of that image. So you see that base image for the base name for the image. So again, like, you can be completely dynamic. I mean, if you have your own custom solution, you can be like, cool, well, I still want these equal analytics to work. So I'm just going to do my own schema mapping, and now the analytic is pure. But that being said, we also have MITRE CAR in here. So where MITRE has pseudocode throughout CAR, you can now take that pseudocode and actually query it, which is great. But the one point, we're not saying this is like, again, earth-shattering, whoa, schema mapping, data model, normalizations. The thing that we do want to point out is, and I think Ross, just kick it to you to show an example here just pretty quickly. If you know your data, you can start querying right away. You don't need equal, if you know the data that exists, you can just start going for it.
Yeah.
Yeah.
And just to show an example of what it looks like to take an equal query and to convert it from our schema onto sysmon, like essentially we're rewriting the query but giving you sysmon fields instead. So I could be like, all right, I want to convert the query, maybe process where, again, I'll do process name is Red Server 32, and command line is script object, has script object in it. And then I want to convert that to sysmon. So if you do want to see what it looks like, so this is equal syntax, equal query, and now we're changing all the field names out from underneath that query to match this sysmon schema that we have right here. And so here's what it would look like. So we didn't specify like creation or terminate events, so it's matching sysmon. Someone asked about event IDs earlier specifically. So in sysmon, event ID 1 is process creates, and event ID 5 is terminates. And since red server 32 is part of the path, we can do */. We could keep going on that, and all that information is derived from what you see on here, which is itself just configuration files. Specifically, like, so where are the event IDs? They're here. So if you say, how do you get image load events out of sysmon? Event ID is 7. So all of those give us enough capability to normalize both the query and your data. So you could take sysmon data and be like, all right, well, I want to actually share this, or I have some like proprietary schema that I don't want to share. You can normalize it and take out all the fields that aren't part of the schema and then share that. As far as you can tell, you don't really know where the data source was. So it'd be like easy, like free redaction or whatever, public standard. Yeah. Was there anything else you wanted to add to that, Paul?
No, I think we could just show like the, at least pretty quickly, then we can get to hunting, but maybe just show like the abstract data real quick.
Yeah. So just for fun, we were seeing like, what other data sets can we play around with Equal? There's a GitHub repo that someone's like collected lists of easy APIs that don't need authentication. So I was like, all right, what questions can we ask for like Nobel Prize winners of the last 100 years? I guess that would be all of them. So yeah, and so we're just going to download this file, this JSON file, convert it to JSON lines, and then it's enough to query over. So within Equal, I'd be like, all right, grab, for this file, just grab the last event, because maybe we want to figure out what the structure is. So this is just so you can see. There's category, year, and then a list of Nobel laureates for who were awarded it. So we could say like, okay, we could also show that within Jupyter, and the rest of the examples will do that. Who won prizes in '84? This one, all the years were strings, so we had to convert that to a string. We could also say like, what was the first year that there were 4 Nobel Prizes, and that was 1919. One last one is how many prizes were there awarded with anything to do with particles? I guess there were 8. I'm assuming that the category for those is physics. I didn't write a query for that, but you can, if you write it, feel free to tweet that. Add event query lang.
Quick question, Ross. If you on some of the previous queries, there's a percentage that comes back. Maybe you could at some point you could clarify.
Oh, yeah.
Just
Data
what that
frames
is.
for the
We
win.
can get to it later. Just something just an observation.
Sure. So if you do pipe count without any arguments, in this case, it just gives you the total count. If you did pipe count category, then it would say for each category what the breakdown was. So if the percent was here with no arguments, it would always be 100%. So that's why it's skipped.
Oh, I see. So it's just a percentage of the total.
Right.
Return.
Yeah.
Awesome. Yep.
But yeah, I think we may be going to hunting next. But the point here, just to make it was maybe just a fun example to do something different. But the point was, we didn't want anybody to think listening in right now and watching that you had to do your own schema mapping and you're like, oh, I got to recompile everything. We just didn't want you to have to worry about that. So if you know your data, then go for it. Pip install equal and start asking questions with my event where key value 1 equals, key equals 1 or value equals 1, whatever it is, your model. So we just wanted to show this as an example. The schema is there to help, of course, but you don't have to use it. So I think it's, probably a good 15-minute mark here. We're going to do like a montage of hunting. I guess Casey, Mike, anything pressing real quick as far as equal-lib, or do you want to just start getting into the montage here?
Yeah, one question that did come in that I think was good, and we can touch on it later, but there was a question about how to contribute to the Atomic Blue or how to contribute to the analytics. So maybe just real quick before we do the hunting or touch on it later.
Yeah, that's a super good question. I mean, so like the embarrassing thing out of the gate is we actually didn't write a contribution guide, so that'll be coming. So I'll just say that. But probably the best thing to know right now is actually, we can even bring it up, but we have, if you want to bring up Tony's, probably the best thing out of the gate is just, we have, when we merged Tony's PR, the conversation that he and Ross had going back and forth was a great way to kind of talk through it. So I think the short answer is more the merrier. I mean, just use the Git repo to push any, make any PRs and we can review those. And as Ross did here, we will work with you to see if hey man, let's make this query even more sophisticated or more generic. And we'll do that. But I think at the end of the day, we have the TOML structure, which we're not really touching on quickly, but behind the analytics library, we just have TOML that's making up these rules. So by all means, just grab one of those examples and you can modify the markup language and make a PR. I mean, that's the easiest way to do it. I think the easiest thing out of the gate would be kind of hopefully inspiring everybody to start sharing analytics. And if you got some CS-minded folks out there that are like, yeah, analytics are cool, but I'm going to go to this language and start doing some elastic mappings or something, then yeah, just hit us up on our event query lang Twitter handle, and we can even just talk there and get some DMs going. But yeah, good question, Casey.
Awesome. Yeah, no, thanks. Yeah, thanks, Paul. Yeah, that was one that came in from the attendees.
Yeah, great question. But yeah, let's hunt. Hunting's kind of cool, so we can just start kind of go nuts here.
Cool. And if you want to, we have data sets already. If you want to play around. So for the sake of time, I'm not going to read out every query and the results. Just show some of the questions you can ask. We've done this before, but what are the parent-child relationships? Just for your own situational awareness, this is always something I start with. Mm-hmm. And then you can take this, do more outliers on it. Or something like within Eql, you could even aggregate events and say which process names are linked to the most number of command lines. So there's a couple of pipes you could use and some filtering to figure out, okay, well, red.exe had 35 unique command lines. And ping was 255, so I'm guessing that was like fuzzing an octet.
And as Ross just said, yeah, we haven't really touched on filter, but you can see it there. I mean, filter, like you would expect it, just another good way to do some stack analysis in the query.
Yeah, and that one I'll use a lot with like counts. Like I'll do like a unique count and then the filter, because then all the data was enriched by like how many times it happened, and I could rip out. I could say like count and then grab the percent is less than 5, or maybe you want to do things across event types. What processes had more than 2 event types? So that's kind of what that query might look like. Mm-hmm. Here's a cool one. So now we're starting to ask more like heuristic-y questions. what things were spawned by parents that made network activity. So this might help you find reverse shells if you tune out some noise. So we can use the equal join to join the PID to the PPID. Or like if you're using sysmon, you just swap it out with the GUID, so that way it's don't have to worry about reuse. This is another like super useful question. Red server 32 calc, that's definitely the is that the KC-APT? Is that right?
I don't know what that is. That looks
researcher
exciting.
APT, yeah.
And Ross said this kind of in passing real quick, but like he said, filter out the noise. I mean, obviously we goes without saying, like you can not and ignore things as well. So we do this all the time. So we'll start with this and we're like, whoa, this is really interesting. And then we just start like ignoring some core processes, maybe some core paths. And honestly, pretty quickly you've groomed your kind of data set or your environment pretty quickly and you get some useful information. So just keep that in mind, like use the power of some inverse queries to help as well.
Yeah, for sure. Yeah, but like inverse queries, speaking of, like even right here, as PowerShell gets noisier, like what files were descendants of PowerShell.exe or PowerShell? And so we could kind of get a list of like, oh, okay, here's all the files and what processes wrote them. So I'm guessing some reg dumping because there's reg TMP in there. Some other things we could ask, what executables were dropped and then executed. So this sounds like equal sequence. So you're going to do a file and then make that path be the process path. And then there's some results.
Yeah, we've done that before. It's kind of cool if you just want to slide up one real quick. I think we've talked about, sequence max span, of course, and sequence by, like you can establish whatever your pivot point is out of the gate. But we've done this a couple times so far already, but you can see how cool that is, where for each query, that sequence of query, you're establishing your pivot point, for lack of a better term, or maybe that is the best term, and you can pivot and then go to your next query. And what's really cool is if you did like a pipe count here, you can refer to those events as if you're talking to an array or a list, right? So you could do like events, of course it's at the 0 element, the first element, the second element, the third element, and you can like start fine tuning and be like, all right, I have this file, I want to unique this file name, but with this process name, right? So anyway, just know that the sequence, kind of think of those as almost like, I don't know, like a list to some degree.
And that's what in the result, they are kind of flattened, but essentially it's like every other result, it's file, process.
Yeah.
Cool. And then did you want to talk to this example at all?
Yeah, so this was like good timing. Man, it's like this never happens, right? Of course, never happens that we don't just start ranting, so this pretty happy about that. But so spear phishing. So we just did all these like hunting examples. So now if we wanted to kind of like go down an analytic path, like, all right, cool, I kind of looked through some things in my environment. Maybe it's like during the morning cup of coffee, you're doing some like hunting grooming, but now you want to write an analytic. So, spear phishing, if we just kind of like jump to the query, I can talk to it. What we want to do is, what would you expect with a spearfish, right? So the root of this is, I'm going to be looking for something as a descendant of Outlook. More specifically, probably a descendant of an attachment I expect to receive in Outlook. And then we can look for that child process. So the big thing here, again, we're not saying that like a direct one-to-one parent-child mapping is something that no one's thought of before. But we'll show here in a second that using that descendant, so hypothetically, if you have, inbound email, hey, here's this WinWord attachment. Oh, this WinWord has this zip file, this jar, this whatever archive, pick your package manager. And then that drops some W script, or say that drops PowerShell, then some W script. Doesn't matter. Like Eql is maintaining state throughout that descendant tree. And so in this query, we basically just say, hey, do we have W script as a child of WinWord? Like I just want to know that maybe there's a macro out there. So that's kind of like where we started. And then, I guess we could, unless there's anything else you want to add, we could just go to the next slide here.
Speaking of macro,
I think that's important because I don't think everybody sees that, like the ability to see like anywhere in the chain. That's pretty cool.
Yeah, and then we'll even make it more robust here, I think.
And speaking of macros, within Eql, we've got this thing called macros that we could take parts of this query and kind of, if we want to be modular in like our analytic design, we could write a query. We could write this, like, here's the reusable parts. Maybe I actually care about Office altogether. And you might have I don't know, a dozen analytics that do things related to Outlook and children and file network activity, but you're constantly referring to the same thing. So we can kind of separate this out within equal syntax, and then we can rewrite our query to use those. So instead, we're using scripting process and office process, and now boom, just edit those macros if you need to change anything. Almost the same question as before, like structurally it is, and so now we've got like 4 results instead of just the 2.
Yeah, we had some.
Those are dynamic too. So as you extend your list of interesting things, today it's those 4, but now all of a sudden you want to go look for OneNote or OneDrive or something. You could simply put that in your list and then re-execute the analytic, right? Like,
that's right. It
doesn't change your action. It doesn't change it abstracts away from the specifics, right?
Yeah, you hit the nail on the head. Yeah, your analytic doesn't change. You can have these macro definitions that you can share within your team and be like, oh, just keep adding some of these interesting files. Maybe you're, maybe you want to have like an app block, or like a bypass script, right? And you want to have like install util, red server 32, and you just want to list all these like Windows native tools that allow for like code execution. You could just have a running list of all those things and look for any time those generate network activity, right? Casey, your point is perfect there, that the analytic doesn't change, and now we can use macros like variables and definitions should be used, and just kind of keep expanding them.
Yeah, that's awesome.
Ross, maybe you want to share this, but I think for the we'll pause here for a second here, Casey, for like questions here. Probably at a good wrap up point too, but we figured might as well just run the works, right?
Yeah. So within this repo, we've got within our library 43, I think now, analytics so far. So what did these look like over this Atomic Red Team test? And this would be great. You want to test your coverage too? You just run equal survey. It'll just survey all the analytics over that file. And we've got 6 unique analytics that were triggered. And then I think it's like 12 results or something. Mm-hmm. So that's kind of just run it all. What's it look like? We can do that.
Yeah, exactly. I think the point just here is that, of course, a smaller data set. Like we're not throwing tons of analytics. Well, we're throwing all the analytics, but it's a smaller data set. But yeah, that's kind of like the first thing we do out of the gate is we'll be like, all right, let's just take our current list of analytics and if the community out there, if everybody like starts contributing here, we could just like add this, and then you just keep surveying. That helps, and then get your, I always say like get your survey out of the way the first thing in the morning, and then you can start doing the hunting the rest of the day, which is a little more fun. But yeah, I don't know. I mean, I feel like that's that was our spiel, if you want to call it that.
That's great. Yeah, I think that of the questions that came in, I think you guys hit all of those. I think just a reminder for folks that the Python notebook you guys will be dropping online, and it's all open source, which is a huge thing. I think we've got a few, maybe another minute or two for questions. Let's see, there's some coming in here.
Questions are live equal riffing. It'll be the
yeah. Oh yeah. So I mean, I think I'll just let you guys kind of close it out. Like maybe how you see people using this, what next steps. Like this is pretty awesome. So there's a question here that came in. Hold on, let's see.
Cool. Yeah, I mean, at least while you're looking at that, Casey. I mean, I think we talked about this earlier, but for folks that are more, it kind of depends on what you like to do, right? If you're more practitioner focused, more analyst focused, and you want to write some analytics, then go hop over to Equalib, which Ross has listed here. If you're kind of like a CS guy, and then want to look at the language itself and start, beating up Ross's brain for the decisions he made for Equal. No, we really appreciate that as well. So yeah, Casey, I think that's the biggest thing I think we would say in wrap up is that we really hope that we can use this as a way to start sharing these, pick your word, analytics, hunt, methodology, behavior, heuristic. I don't know. That's a whole other discussion, but we can just start sharing those type of questions that we want to ask of data. And I think that'd be the coolest outcome.
Yeah, this is great. Really a huge thanks for you guys showcasing this, and also like, contributing to the community, because the fact that this is now open source and available for people to study and start snapping things together is one of the reasons we wanted to have you guys on and kind of showcase some really awesome work here that I think's really valuable. So thanks again.
Yeah, we appreciate it. Thank you guys.
I think, yeah, I think there's one other question came in, I think, and then we'll kind of wrap it up. Somebody was asking a little bit about JSON. The question was basically, aside from JSON, what's the best way to connect to your data source? I mean, are there other connectors? Are there other things? Maybe I'll let you guys answer that one.
Sure. So right now there's still, or was there anything you want to?
No, go for it. Yeah, that's
within Eql. So I guess the biggest thing then would be, you could write stream data. If you get JSON output, you could stream it right through the console. I don't think we showed off today, but it does take standard in. So you could do it that way, but if you have but that would also defeat a little bit of the purpose of why you have databases.
Sure.
Streaming 5 gigs of JSON through standard in, it'll work. Equals probably won't crash because it'll maintain state intelligently, but I'll still have to touch every row in there.
Okay, cool.
yep.
So for hooking it up to your own thing, we do have an API guide, and we don't have much in there yet, but there is this Python engine. Essentially, is what's built natively, but within this Eql source, wherever that's at. There we go. We have a handful of base classes essentially. So if you do want to write your own thing and essentially compile the syntax into something else, we've got a lot of helper functions and some references to for how to convert from Eql syntax into something else. So it still would have to be written, and we'd be glad to work with anyone or talk about any particular things. But right now, the framework is there to do it, so you'd have to connect and translate.
Okay, cool.
Yeah.
Yeah, I think just for timing wise, I think we're kind of wrapping up here. I've got, but I think if there's any questions that came in that we don't get to, we'll be sure to throw them out on the blog or find a way to get those answered. So really, really good stuff. Anything else before we kind of close it out?
Yeah, one last thing from this side. We do have an Atomic Red Team survey that is out there. It is within the link is within the Slack group, and then I believe we'll also ship it out through the Atomic Friday follow-up email for that as well. So any and all feedback on this or any other content anybody would like to see, please provide all that in there. That'd be awesome.
Awesome. Great stuff, Ross. Paul, thanks again.
Yeah, thank you guys.
Post the link. Once the recording's all done, we'll have it ready and ship that out too. So thanks again, guys. Appreciate it.
Yeah, thank you everybody for joining. Have a good day.
Yeah, thanks.